Good morning, ladies and gentlemen. This is Mr. Smith, and this is 6.4 Perimeter of Composite Figures. Now, remember what I said, 6.3 is area of composite figures. I find it a lot easier to learn that way. If you know area, it's pretty straightforward. Perimeter is a little bit trickier because there's a lot of extra calculations you'll have to do. So take your time working through this. Recall that perimeter is the sum of all the outside edges. Do not use perimeter formulas for common shapes when determining perimeter of a composite figure. So you can't use your formula sheet. That's not going to really help you. Not overly. You're just adding up all the lengths of each side to figure out the perimeter of a composite area. So in order to actually determine the perimeter of a composite area, first you have to determine the number of outside edges it has. Then you need to determine the measure or the length of each edge. This sometimes involves using logic, Pythagorean Theorem, or circumference of a circle formula. So there's all of those things you have to consider. Then once you have all the measures figured out, then you add the lengths together. Our first example is a little bit more straightforward. It is still a little tricky. You still have to think about it. Determine the perimeter of the figure below. Now this isn't to scale, so if you're measuring with a ruler, it's not going to work. So we have to actually think about this critically. First, let's determine what this length is here. Now, we know this length at the very top is 14. Right here is 14. And we know down here is 3. So this length here should be 14 subtract 3, which is just 11 centimeters. Then we're going to determine this length here. Now, in order to do that, we know our outer length, or our larger length here, is 10 centimeters right here. And then our smaller length to subtract from it is 4 centimeters. So this is really going to be 10 subtract 4, which is just 6 centimeters. Okay, so now we have all the sides determined. We can actually add them up. Just reading this clockwise, I'm going to start with 14. Then add 4, then add 11, which was the first one we determined, then add 6, then plus 3, then plus 10. And it helps to go in order. If you're adding all over the place and not reading the numbers in order, sometimes you'll add them twice and end up with a mistake. So if you add them together, you should get 48 centimeters. And it's not centimeters squared because it's perimeter, not area. Okay. Next slide. Here we have two sides given, but we're not given the third. Down here, let's call it side A, lowercase a. And if we think about a right angle triangle, we have to use something to determine this side. What would you use to determine this side? If you said Pythagorean Theorem, you are correct. So our Pythagorean Theorem is a squared plus b squared equals c squared. Well, we don't know what a squared is, so that stays a squared plus 20 squared equals 25 squared. Then we're going to end up with a squared plus 400 equals 625. Then we're going to end up with a squared because we moved the 400 over like we've seen countless times before. You guys should be pros at this by now. You subtract it and you have 225. A squared over here. To get rid of the squared, you take the square root. You have a equals 15. Okay, so this is going to be 15 centimeters here. Now we can actually determine our perimeter because we just add up all the sides. I'm again going to start going clockwise. You can start with whatever number you want. I'm going to start with 25. then I'm going to add 15, then I'm going to add 20. And once you add 25 plus 15, that's 40 plus 20, that's 60 centimeters. Done. Okay. Moving on to the next example. Here we go. This one is a little bit more complicated because there's a bit more to examine. We're going to take a look, and we have to determine all of the outer edges here. We're not given all of the outer edges. We need to figure out, let's say this is side X, and I'm going to use green for side Y. So this is side Y, and we need to determine both X and Y. Now, we don't need to determine the bottom of this shape because it's 16. We know that because the top is 16. So I'm going to go ahead and label this as 16 centimeters. Because right now, looks like we have a half circle, a rectangle in the middle, and a triangle on the other side. So first we need to determine either X or Y. Let's start with X. It's a triangle, and already it's a right angle triangle. We should know what we're going to use. Should be Pythagorean Theorem. Now, which side is the hypotenuse? Well, if you take a look, X is our hypotenuse, so it's actually going to be 12, or a squared plus b squared equals c squared. And in this case, our c is going to be X. So I'm going to plug that in right now. 12 squared plus 5 squared equals X squared. 12 squared is 144. Plus 25 equals X squared here. We get 169 equals X squared. Take the square root of both sides, and you should get 13 equals X. Okay, so that's our first side here, 13 centimeters. There we go, just dividing that a little bit. Next, we need to determine Y, and in order to do that, I'm going to use green to help me out. Just to match up the colors, we need to use our circumference formula. And just a quick reminder, our circumference formula is pi 2 pi r, or pi times diameter. And we do know the diameter. It's given to us. It's 12 because it's right here. So we can use that on both sides. This would be 12 over here. However, this isn't a full circle. It's half of a circle. So we actually have to divide this by 2. Remember, half of a circle is going to take the formula for a full circle and just divide it by 2, whether it's perimeter or area in this case. So now we need to plug in all of our numbers. So it's just pi times 12 all over 2, which is just 18.85. Whoop. There we go. Centimeters. So now we know what Y is. This is 18.85. And finally, to calculate my perimeter, I'm going to switch to black because there is a lot going on here. For my final perimeter, I'm going to start at the top. I'm going to start with 16 and work my way around. I'm going to go to 13, so 16 plus 13 plus 5 plus 16 again plus 18.85. Now, I put a note in that says 12 centimeters isn't included because it's not an outside edge. Notice that it's not along the outside. We're only counting the outer edges. So in this case, we don't add 12 into this equation. And when we add 16 plus 13 plus 5 plus 16 plus 18.5, we get 68.85 centimeters. Okay. And that's all there really is to it for calculating the perimeter of a composite figure. It is a bit trickier. It takes a bit more time. There's more calculations, and it's kind of combining everything you've learned up to this point. There's algebra, there's Pythagorean Theorem, there's circumference. So take your time working through the practice before going on to the quiz. If you're struggling with the practice, make sure you ask questions. You can always email me. I'll respond as quickly as I can. But You should do your practice first, then your quiz, and everything should be good. If you mess up on the quiz, no sweat. You should be able to redo the quiz. Because I'm trying to give you guys as many opportunities to improve your mark as possible before the end of the semester. All right, that should be everything. I hope you guys have a great day, and good luck.